Okay, now, this was a general example. Now I can give you a statistics example.
We get a spreadsheet.
Wait, what? Why do we get a spreadsheet? Thank you. Okay, this is why I was looking for my box of pennies.
When I sneezed, so you hit me with them?
No, because we wanted to do this exam. Somebody read.
Suppose we have 3 distinguishable pennies and we toss them. How many possible outcomes are there? Assume that all coins are fair and the probability of each outcome is equally probable.
Okay, so there are 3 pennies and we are tossing them. You want to draw that picture? Heads and tails, right? Anyone from statistics remember how we do that? How? Snake.
Drew a tree.
Do a tree?
Yeah. Quick question.
Two
Two branches, heads or tails, and then 2 branches off that, heads or tails. 2 branches off that, heads or tails. And then you're done. For that. I like the tree.
So how do you find the probability when the probability is only heads or tails? 2 to the power n. How many pennies do we have?
3.
So it will have how many outcomes? 8. That's it. That's what statistics tells us. Okay, so for penny 1, for penny 2, for penny 3, how many states could exist? 1, 2, 3, 4, 5, 6, 7. Oh, I messed up. 8. Maybe one more line. Okay, let's start with the probability, the most likely one. All heads.
How's that most likely?
Oh, not most likely, but like easiest to do. Or it could have all tails. Or it could have 2 heads and a tail. Or it could have 1 head and a tail. Or, oh, I should have done tails here. Would have been easier. Sorry. Then we do the other way around, right? Tail, tail, head. Then we will have a tail, head, head. And then we will have, wait, what am I missing? Heads, tails, heads, yes. And one more? Head, tail. Thank you. These are all the possibilities, right? Now, defining them in terms of statistical mechanics. Each of these states will be called a microstate. Get it? Each state is called a microstate. Now, how will I make macrostates? If I am only looking at how many heads or tail, but not individual states. So how many states will just have heads? There's only one state that only has 1 head, right? Okay, how many states that only have tails? How many that have head, and 1 tail? Is there?
Yeah.
No, but there's this one too.
Well, in that order.
No. I don't care about the order. Right? There's this one, and then there's this one, and then there's this one. 3? That's it, right? 3? Okay, cool. And then what about if I have 1 head and 2 tails? How many states? 3? Any other?
Nope.
These are called macrostates. Get it? So how many macrostates for this ensemble? Right? And another thing is called omega. It is the multiplicity of the macrostate. And it is defined as the number of microstates that correspond, hello, to any given macrostate. So what's the multiplicity of head? Good. So can I write this as omega for heads only?
Yes.
1. What's the multiplicity of 2 heads?
3.
Oh, I'm sorry, 0 heads.
1.
What is the multiplicity of 2 heads?
3.
What's the multiplicity of 1 head?
Also 3.
Good. What is the total multiplicity?
8.
Yep. Total multiplicity equals 8, which is also given here. Cool?
Makes sense.
So the total multiplicity is 8. The probability, this is important, probability, can I spell that right? Of any particular macrostate is then given as n divided by all. So the probability of, pick one.
2 heads.
Probability of 2 heads will be given as 3/8. Yes, sir.
Is that in systems with chances that are not equal?
No.
Oh, okay.
So equal probabilities.
For equal probability.
Yeah, this lasts for only equal probabilities. Which is going to lead me into the statistical question, right? Of n. So I want you to put this in a box. For n coins, that are distinguishable, the multiplicity of the macrostate with n heads can be written as nn or n factorial divided by n factorial n minus n factorial. You see how that developed? We all know what factorials are. And I am going to put this in a box and color them in.
First number, second number.
Yep. So a factorial of, pick a number.
5.
5.
The combination.
5 factorial is? That's all it is.